Hi, my name is Dale West, and I'm a STEM teacher here at Joliet Central High School. This is my 15th year teaching, and this is an example screencast for my Orientation to Technology class of the Rubber Band Dragster project. A quick tip for my students: if you are in the process of doing your own screencast, I recommend that you print your slide notes to help you narrate as you move through the screencast. How do you do that? If I just hit escape and I go to File, Print Preview in the Google Slideshow, you can then go up here, see where it says one slide without notes. That's what's going to be on the first page, but we want the slide with notes. So every slide is going to have its own page with the bulleted notes or notes that you typed in on the bottom, and here you're seeing an example of that. And then you could send that to the printer in the room. If I hit Close Preview, the other option that you could do to help you narrate along the way is if you have the opportunity to use dual monitors, you can go over here and go to Presenter View, and then you can take your slide with the notes and put that on your second monitor, which is what I'm doing to help me narrate this video. So a quick overview and to help the viewer know what to expect as they're moving through this screencast. First, I'd like to quickly summarize what the Orientation to Tech class is. This class is geared towards our incoming freshman students to give them a preview of many different vocational classes we have to offer here at Joliet Central High School. These students will have the opportunity to spend roughly 2 or so weeks in classes like photography, engineering and drafting, woods, automotive, computer maintenance and repair, electronics and robotics, metals, and welding. My goal for this project is to build a rubber band powered dragster out of wood based on computer aided drafting blueprints which I created. I want to use this screencast to show you my project from start to finish, and I will share the skills I've gained, the troubles I faced, the results, and the modifications I had to make along the way. Finally, I will reflect on the project as a whole and share my overall thoughts. So this project first started in the engineering and drafting unit, where I was exposed to computer aided drafting, or CAD for short, CAD. I used the CAD software Autodesk Inventor to create a 3D model of the rear and front wheels. We followed a video tutorial to learn how to create 2D geometry and transform it into a 3D shape based on specific dimensions and criteria. If you start from left to right in the images below, you'll see this process happening for the rear wheel. So you're seeing here, right here in this image, a 2D sketch with a specific dimension, and then transforming that into the 3D object to create a rear wheel. I really enjoyed this and found it very rewarding and seeing how the wheel would come to life. And actually, after we did the rear wheel together, I then had to take those skills that I learned to create the front wheel all on my own, which really did help me self-assess and see if I could take what I learned and apply it and remember it and do it all on my own. From there, we moved into CAD drawings. So after we finished that 3D model, we learned the importance of orthographic drawings and how they impact every industry in our world today. Everything we use or interact with today has to start with a detailed drawing before it's actually produced. These drawings make sure the product is meeting the expectations and are accurately manufactured. I learned that an orthographic drawing typically consists of a front, top, and right side view. And also in addition to that, you'll typically see a shaded orthographic to help the viewer visualize the 3D object. Here you are seeing the dimension drawing I created of the front and rear wheels for my dragster. I learned what center marks and center lines are for. I learned how to properly fill out the drawing title block. And finally, I learned how to adjust the precision of the dimension and how this can potentially add cost to the manufacturing process for this actual part or parts. In the woods unit of the OTT course, we started to see the connection between the CAD from that drafting and engineering unit and the physical construction of the rubber band here in our woods unit. Here you're seeing me use the body CAD drawing to begin the construction. I first used a chop saw to cut a 2x6" piece out of 3/4 stock. I then cut out the top view of the CAD drawing with scissors and traced the body design on the top of my piece of wood. I also realized why it's important to be able to read a tape measure here, because you really want to make sure that you're meeting the specifications of the CAD drawing. Next, I used the bandsaw to begin making relief cuts for the curved portions of the design. This allowed me to easily cut these portions out of the bandsaw, since the blade cannot bend while cutting the curves. If you follow the images from left to right below, you can see that body design begin to develop. So from here, moving to the right, and then finally I was left with this. Next, I used the paper cutout of the top view CAD drawing and placed it back on top of the wooden body. I then used the pointy object to transfer the center of the flagstaff and the motor pin holes to the top of the body, and you're seeing that in the far left image on the bottom. I did also learn a little trick along the way in putting some painter's tape at a specific location on the 1/4" drill bit. Why did I do that? Because it helps me see how far I'm drilling down into the object and make sure I'm getting the desired depth that was given to me in that CAD drawing, and I don't go too deep. I then put the drill bit in a hand drill and eyed up a 15-degree angle to drill those 2 holes in the top of the wood. Next, I used the front view of the body CAD drawing to help me determine the location dimensions of the front and rear axle holes. I used this information to create a center mark with the pencil at a specific location to ensure my holes were exactly where they should be and met the CAD drawing specifications. I then used a 9/32 drill bit in a drill press and drilled the holes all the way through the body. I then tested some 1/4" axles that I cut to the correct length with a bandsaw. This was to ensure the wood would spin, or that it would spin smoothly. Next, I used the bandsaw to cut the flagstaff and the motor pin out of 1/4" dowels to the correct length. I did another dry fit to make sure I was happy with them. Here you're seeing the CAD drawing that was generated to help me see the various lengths of those different dowels. And then here you're seeing the dry fit. For the wheels, I used a hole saw drill bit in the drill press. This type of bit is typically used to cut a hole out, but we actually took the circular part that was left and used it for our wheels. I referenced my CAD drawings to determine that I needed a 1" and a 2" hole saw drill bit. After cutting them out, I had to cut the 1" circle in half to create 2 front wheels. And then I used the 2" to cut out 2 different rear wheels. I then sanded and dry fitted again to make sure everything was proper and that I was heading in the right direction. When moving into the decoration portion of the project, I decided to try something new called hydro dipping, and I was really excited because I've never done anything like this before. So yeah, let's talk about it. I researched and watched some YouTube videos to determine the materials that I'd need to get and the process I would need to follow in order to be successful at this. Here you're seeing me gather some of those materials and begin to use some eye hooks to apply a base coat of the wooden body. And I put those eye hooks on the bottom to allow me to easily hang it and let it dry nice and neatly. So here you're seeing a quick time-lapse video of the hydro dip process, as well as the end results of the body on the right. And in the top right, I just ended up spray painting the remaining parts. I did notice that after everything had dried, the parts were a little bit harder to assemble during the dry fit. Overall, I was very pleased with the outcome. Kind of created this kind of cool tie-dye kind of look. I was trying to get more of our school colors of, blue and gold, but I did notice that as those rings started to intersect one another, when you start mixing that blue and yellow, you do start to get a little bit of green, but overall I was very happy with it. And again, like I said in the last slide, due to the paint causing some friction between the different parts, I did have to go back and do some additional sanding to get everything to turn smoothly. I also referenced the exploded assembly CAD drawing to make sure I was putting everything together correctly. So in trial number 1 here, and I'll play the video for you in a second, but you'll notice that I've already added some electrical tape to the back wheels. And this was because I started to notice that there wasn't really any traction when you actually wound it up and put it on the floor, and it would just kind of do a burnout, so to speak. And I felt that maybe the electrical tape would give it a little bit more traction and help it grab the floor as the wheels turn. But let's take a look at this one. And again, you could just see it kind of do that burnout and spin. I then thought, what type of material are vehicle tires already made out of that we drive around every day? And then I just thought rubber, right? So what are the materials that are made out of rubber that I could use, that I could easily access and, make a modification to my Dragster? So I decided to add some rubber bands on the back tires. And I found that I actually had to wrap a few more strips of the electrical tape because the rubber bands were a little bit small and weren't staying secure onto the rear wheels. So by wrapping the electrical tape around a few more times, it made the tires a little bit bigger in diameter and allowed those rubber bands to fit nice and firmly around the tire. And we'll play trial run 2 for you right now. So you see that we're getting a much better result. There is traction and the vehicle is moving forward, which I am much more happy with. In the end, I realized that I had made many different iterations of my Dragster due to the modifications I was making along the way. I did the additional sanding after the paint due to the friction between the parts. I also had to sand a chamfered edge on the front bottom edge of the car due to it rubbing on the ground, and you're seeing that in the second image. Finally, I had to modify those back wheels because there was no traction and we just kept doing burnouts. The first thing I would do differently is to make sure I use a drill press for the axle holes because they must be perfectly straight or perpendicular to the front view of the body. I think my holes were a little angled due to me missing or not being able to use the drill press and having to use a hand drill since I was working from home. I feel that this kind of slowed my dragster down because my holes were a little bit angled and not going perfectly straight through. I should have also drilled those holes prior to cutting the profile of the body because it would have been a little bit easier to drill them at that stage in the manufacturing process. The other change I would have made was to test the hydro dip on a piece of scrap to kind of figure out those problems that I may run into ahead of time. And then finally, some of the other things that just kind of came out through the project that I realized was the first version wasn't my final version. I think nowadays, we're so used to just getting that final answer, that final product right away, that we have to sometimes just slow ourselves down and go through that process because that's where you're really learning how to troubleshoot. And troubleshooting is a really good skill to have in any future career. And then also something else that came out to me was failing. It's okay to fail and you should fail, but you want to try and fail often and fail quickly so you can get to that final version or final iteration of your design. but it's okay to make those or to fail and then make those troubleshooting or to troubleshoot through it and then fix it. And then finally, I did make some really good connections between the industries and those class units that we've been going through. I really saw how the CAD drawings really affect the overall design while I'm actually producing the product and making sure I'm following those CAD drawings to produce a specific product and make sure that I'm meeting those expectations. And it would also really helped me guide my decisions for next year. Do I want to jump into woods and go take that class my next year of school, or do I want to go more on the engineering side and take engineering and architecture 1? Overall, though, the project was fun. I really did enjoy it, and I look forward to our next unit. And finally, I just want to say thank you for your time. I want to give a shout out to Mr. Popek, an old teacher or a retired teacher, I should say, from Joliet West, who started this project a long time ago and just hadn't come back. And I thought about it and thought it'd be perfect for this class. So I want to give a shout out to him, and just a shout out to some of the other teachers that I've been working with, Mr. Fabris, who's been helping me along the way and giving me some ideas as well. And thank you for your time and following along with my rubber band dragster project.